way.
Thanks, sir.
Tell me when you're ready.
Oh, yeah.
You got everybody?
Yep.
Good morning. How's everybody?
Good.
I am Mike Cook with ESOP, formerly Vector Technologies. I've been in the industry 33 years now. Work for distribution, work for Vector, Thermal Dynamics, Tweco, all that, and then about 2 years ago,
Yeah.
we merged with ESOP. So, worn lots of hats. We have a lot of knowledge here. This is Ed Bohr. He's with ESOP also. He came from the legacy side. He's the ESOP, the welding side. And so we work together a lot. He helps me on some of the fellow metal stuff that I'm not as, familiar with, and I help him on some of the torch training stuff. We also have gas and supply here. Aaron, he's, are you their
Yes.
guy?
I'm
Okay,
the
I want
guy.
to make sure,
I'm the guy
because I
now.
got everything from.
Now.
I'm the guy now.
He's your local distributor, so he's your Tulsa guy. Ed's here in Tulsa a lot. I cover western Oklahoma, basically from Stroud west, Kansas I-35, I-70 west, and the Texas Panhandle. So anyway, I appreciate you coming in on a day that's not yours. This isn't your normal day. For safety meetings, I believe, if I remember the emails right. So that was on me. Don't blame Jason. That was all on me, because I'm usually in another state in the middle of the week. I leave on Mondays, usually come back on Thursday, so we came back early so we could do this for you guys. I do want this to be a conversation and not me just standing up here spitting out a bunch of I won't say worthless information, cool information about torches. So, please, if you have a question, ask it. If the one of the three of us don't know it, I will make this commitment to you. I am very good at follow-up. I've been doing this a long time, and my saving grace is, if I don't know something, I'm not afraid to ask. I'll go do my best to dig out the answer for you and get back with you. Fair enough? I always start with PPEs. Leather shoes or boots. Tennis shoes are a no-no. Believe me, you can look at a lot of them I've had in the past at home, and socks that have got burn holes in them. Long cotton or FR pants, long sleeve or FR shirts or leathers or something along those lines. Gloves, leather welding gloves. Depending on what you do, they may be the heavy welding gloves, or even the light, TIG weld or MIG welding gloves are sufficient in a lot of cases. What I don't want to see you do, or Jason doesn't want to see you do, is using the, I call them mechanics gloves. It's got the spandex on the back. Some of them, like Oilfield uses them a lot. It's got little knobbies on there to keep from impact. Those things, if you get a piece of slag or dross on it, it's going to melt and create a much worse burn than if it hits a good pair of leather. Those things are treated for fire. You use the right type of gloves. Glasses, safety, I wear prescription, so I use a visor. Whatever you use, you want to use something that says shade something. Sunglasses are not okay. We want something that will take out both the infrared and the ultraviolet rays. Okay, and that's what your actual cutting goggles or cutting visors will have. Sunglasses don't take out both the UV and the IR rays. Okay. Did everybody get a book? I didn't ask that. Shame on me. And a red tip copy. Does anybody not have one? These are yours to keep. It's great reference material. Great bathroom reading. Any questions on PPEs? To me, that's the world we live in today. It's very important. Confined space, I'm not going to spend, this isn't really a confined space discussion, but I will say, and you need to know, that for every 1.1 cubic foot of oxygen that is consumed through the torch, that you're pulling out of a tank, you are consuming 1.4 cubic feet of oxygen out of our ambient air. So most people think that the oxygen is all coming through the hose and through the torch. That's not so. Air is 21% oxygen, 79% nitrogen. There's trace elements, argon, and other gases. Okay? It takes 17% of oxygen to sustain human life. Gives you a 4% window. So if I'm in a tank or in a confined space down in a hole and I don't have fresh air coming in and pulling it out, asphyxiation is a very real possibility. Okay? So that's my little lecture on confined space. You guys probably do get into confined space at some point. And I see some smiles, so I think I'm pretty well on the mark.
Most of them are in it about every day.
Absolutely. Okay? And we're using this stuff. Same thing goes with any type. We've got slice rods. I know I've done a slice training in here years past. I'm an old fart, so I've been here before. Who have I seen before? Just out of curiosity. One? Okay. Jason and I were talking, I think it was been about 14, 15 years when I did the first one here, when we first met. About a year after he started here. But anyway, so, be careful. Keep that in mind. I'm not going to get into all the chemicals and stuff that might be in the metal or in the tanks or anything that you're cutting. That's a whole nother discussion. You've got safety procedures for that if you got monitors. But the real concern, no matter what's in that area, is asphyxiation. Okay. Any questions on the PPEs or the confined space? These torches work off of two things: oxygen and fuel. And we feed them with pressure and flow. So oxygen comes out of the air. The air separation facilities are basically that they get oxygen is basically huge air conditioners, and they super cool the air down until it gets to 297 degrees below zero, and the oxygen that's in the air turns to liquid. It hits what we call its boiling point. Once it turns to liquid, okay, it looks just like this water, and it goes off into a super insulated vessel. it condenses down considerably. So we can transport it. We can transport large quantities of oxygen in a liquid form, okay? We keep going to 300 and I believe it's 4 degrees below zero, and we get argon. Argon goes to another super insulated vessel. We get down to 320 degrees below zero, and we get nitrogen. And nitrogen goes off to another one. It's 99.99 plus % pure gas or liquids at that point. From there, they take it to places like gas and supply. They put it in a stand tank, and then when they pump it into your steel cylinders. Okay, those steel cylinders are all regulated by DOT, or Department of Transportation. When you transport a cylinder on the truck, it must have the cylinder cap attached or another approved safety device on that valve. There are a few that are making them. We don't make them. Aaron can probably tell you who they are, but there are a couple of them that will allow you to leave the regulator attached, okay? You guys probably won't get a ticket because you're the city. They don't ticket themselves probably, is my guess. But if you're at home and you're driving down the road, these oil field rigs and stuff, they get tickets all the time. They'll leave it in there. Texas is really, really strict on it. So, oxygen, high pressure cylinder, the biggest hazard, or one of the biggest hazard, is falling over and shearing the valve off. Okay, the valve is a weak link. It's brass and it can come off. Did anybody ever watch the show Mythbusters? A couple of you. Have you ever seen the episode where they tried to shoot a high pressure cylinder through a brick wall or cinder block wall? Go Google it sometime. It's about a 4-minute video. It's hilarious. I laugh, and I've seen it 100 times. But one of the things that everybody talks about with high pressure cylinders is that if you shear it, it's got enough force to go through a cinder block wall. So they actually wanted to dispel the myth. These guys have a great job. They get to do all kinds of goofy things, and they really enjoy it. But so they got this building, they put a piece of channel down, they set a cylinder, they pressurized it to over 2,000 PSI. They had some contraption that came down and sheared off the valve, and they got cameras in there, and they're standing outside, and they hear it hissing and banging, and all of a sudden you hear a big crash, and they walk in there and they just giggle and carry on, and there is a perfect mouse hole where that cylinder hit that cinder block wall, went through, hit a second wall, and moved it about a ½ inch. There is a lot of force in these cylinders. I cannot stress enough to keep these things secured. Okay, that is all our high pressure cylinders. Okay, doesn't matter whether it's argon, nitrogen, your C25, oxygen, those are all. You never take the cylinder cap off unless it is chained and secured before. I don't care if it's empty, you put it on before you unchain it or unsecure it from its position. Okay? Oxygen is not air. It is non-flammable, but yet it is one of the 3 parts that is the triangle combustion. Who can tell me what the 3 parts are? What's the 3 things that it takes to have a fire?
Oxygen, fuel, and heat.
Oxygen, fuel, and heat. Perfect. The absence of any one of those 3 things, it is impossible to have a fire. Oxygen and oil, or petroleum products, are 2 of those things. All we need is pressure or flow, which creates friction, which creates what? Heat, to complete our triangle combustion. It takes very little pressure of pure oxygen in certain petroleum products to create a flash fire. Okay? We never blow ourselves off. We don't dust off our tables. Oxygen is oxygen. We have compressed air for those duties. okay? The thing you don't wanna do, you blow yourself off, it gets trapped between your clothes and your body. The guy next to you either lights a cigarette, picks up a grinder, all of a sudden you got pure oxygen, your fuel, your clothes are fuel, and you go up. Okay, severe burns result. We never, ever use any type of lubricant or petroleum or lubricant or sealer on any gas apparatus part. Okay? Everything on these things and regulators seals gas or brass to brass or brass to copper. This nipple seats to the inside of your acetylene cylinder. When you tighten up the nut, it pushes it and seals it. Putting Teflon tape or pipe dope around these threads do nothing to fix the leak. Okay? It's going to come behind it and right out the back if you have a leak. If you have a nick in here or a scratch or a dent or something, that's where the leak is coming from. Okay? Putting all the Teflon tape, pipe dope in the weld ain't going to help you. It's just going to create more problems. The same thing goes when we look at the torch. When we hook up the hose, it seats on the inside here. It doesn't seat on the threads. All the threads do is help suck it up. Okay, so if we have a leak, and we're going to go through leak test here in a little bit. Oxygen cylinders, I don't care if they're standing up, laying down, upside down, as long as they're properly secured before we take off the regulator. It's a hollow seal cylinder, and the pressure out of them will come out and satisfy the regulator and the tool. Okay? The other part, a fuel. Now, I will say if you're using Victor torches, the vast majority, we do have a few specialty torches, but the vast majority of our torches will operate off of any fuel gas. Okay? Doesn't matter whether it's propane, propylene, natural gas, acetylene, hydrogen, methane. If I could bottle your farts and put it through on this torch at a positive pressure, I got a torch my torch will burn. Okay? All we need to do is be conscious that we have the right tip, the right regulator, and the right gas hose. Okay? We'll touch. Tips are designed for specific gases, for the burning velocities of the different gases. So if you change fuel gases, you need to make sure that you change and use the right proper tip. Gas hoses. There are 3 types of hoses, R, RM, and T. R and RM are safe for acetylene use only. Grade T is safe for any fuel gas. So if you have an application, maybe you're doing a lot of heating and cutting and you're using propane or propylene, chemtane, one of the alternative gases for heating, and we'll get into this more, and you're going back and forth, I highly recommend using grade T. That way it doesn't matter which one you do. Now, let's touch on, it was here, regulators. Okay? These 2 regulators, acetylene, alternative fuel, propane, propylene, chemtane. Fittings are exactly the same. I can screw these on either one of the cylinders. They'll screw on and work just fine. Work just fine as a nut. Right. They will function. Okay? They are not right. CGA and NFPA, our governing bodies, state that you must use a regulator for the gas service for which it's designed. Acetylene, there are 2 rules of acetylene you must remember and follow. They're not Victor's rules, they're just international rules or functions of that gas. Number 1, we never exceed more than 15 PSI. And number 2, we never exceed more than 1/7 of a cylinder contents per hour. Let's talk about the first one, the 15 PSI. If I have an acetylene regulator, it has what? It has a red line at 15. Every acetylene regulator that you will get from us will have a red line at 15. There is no such red line on a propane regulator. This regulator will only deliver max about 16, 17 PSI. All the way in. The springs, everything internally is designed not to get you into a dangerous situation. This regulator will deliver 40 PSI, and we have another one that looks just like it that will deliver 80. Now, why do I make a big deal out of this? First rule of acetylene, we don't exceed 15 PSI. Why? In acetylene gas in its free state, in other words, out of its cylinder, is a triple bonded molecule, and it has the propensity to, whenever the pressures get too high, the molecules want to separate, and when they do so very violently, and they will explode. Okay? Now, you ask, I got a cylinder here and it's got 300 PSI, 250. Is this guy nuts or what? Well, that may be, but that cylinder is specially designed for acetylene. It isn't a hollow steel cylinder like your oxygen is. It has a porous mass inside of it, and I kind of equate it kind of like a sponge. Okay? It holds the acetylene gas, and it also has acetone, which is a flammable liquid, pumped inside it. So if this was a Coke, and I opened it up, what would you hear? What is that? Psst. What is that sound?
Gas escaping air.
Gas escaping. Anybody know what kind of gas that is?
Carbon dioxide.
Carbon dioxide. Okay, we call that it's in solution. Okay, we could say a beer too, but most of the beer bottles aren't clear, we can't see them. But if you open it up, you see the bubbles come out, right? But we don't really see the gas. We see the result of the gas escaping. Okay, acetylene is the same way. We've got a cylinder with a porous mass with acetone, and then they pump the acetylene gas inside of it, and that gas is in solution. So when we start using our torch, we need to pull the gas out of that solution. There's only so much that we can get out at a time. That's why we have the second rule of the 1/7 of a cylinder contents per hour. If you look, and remind me, because notoriously I forget this more than I remember, you'd think after all these years I'd remember. There is a number written on the shoulder of your cylinder. Okay? You guys are using the big cylinders out there. You may have smaller ones in your truck, but the big cylinders are typically between 300 and 400 cubic feet. There's a painted number that tells you how many cubic feet's in it. I like simple math. Okay, I'm a simple person. If I have 350, 1/7 of that, I would have 35 divided by 7 is what? Anybody? 5. Carry my 0. Now I have what? 50 cubic feet of acetylene that's usable. Okay, it's real easy. You can round up and down, you know. But then we give you, everybody here has got a tip card for acetylene, and we have a book, and it's got the same information in the book. But if we're cutting, I will just tell you, unless we're cutting some really big stuff, I mean, we're talking 6, 8, 12, 36 inch, those things are going to usually cut with alternative fuel anyway. You're not going to have an issue with withdrawal rates for cutting. When we get to heating, it becomes a real issue. And we're gonna go into heating in a little bit later. But if you look, we give you the acetylene consumption per hour for every size tip, acetylene tip that we make. And that's because that's a real issue. Okay, we'll come back to that here in a minute. Acetylene cylinders must always stand upright. Okay, because we have acetone in there. If I put this water bottle at an angle, I know water's a little hard to see, but what happens? Where's my water at?
Goes at an angle.
It's up in the valve, isn't it? I run that possibility. I also restrict my opening in the valve. So now, even if I'm not sucking the acetone out of it, I'm still creating a tighter for that gas to come out. AWS, American Welding Society, states that if you lay an acetylene cylinder down, it must remain standing 30 minutes prior to being put into service. Okay? We want this thing to normalize. We want that acetone to settle down. We want the acetylene gas to settle down inside that cylinder. Okay? There are times that you're going to have to transport one laying down. Just make sure before you get to the job site, you stand it up, you have it ready, you do something else in preparation and give that cylinder a chance to normalize. Okay? Propane and those type gases should never be laid down. Okay? They have a little safety in the top and in the valve, and if they get any of that in there, it can pop that safety off. Absolutely no circumstances should any gas be transported in an enclosed vehicle. Most gas suppliers will not even sell you or allow you to load a car putting stuff in the trunk. There's pictures, I don't know if you guys have pictures in your store. Most suppliers, when you walk in, they'll have a picture of a car that's just a van that's blown up, and it can be with a little bitty plumber's bottle or a 20-pound barbecue propane grill. You put them in a trunk, they get hot, the gas escapes, you open it up, now we've completed, you get a little spark in there, it could be from a light, it could be from the opener, whatever the case, could be just friction. Could be static electricity. And when it goes bad. Okay? So we all have barbecue grills, guilty as charged. I will tell you, if you're, and I do this myself, if I don't have my truck, I gotta have it, and it's in my Tahoe, the windows are down, I make sure that sucker is standing up. Obviously, no smoking. You go straight from one spot to the other. You do not put them in enclosed vehicles. Okay? Any questions on the gases? I know I went, it's kind of lengthy, but I think it's important to know what you're dealing with, along with how to use it. Any questions? All right. One of the highest probabilities of having an accident is when you go to change out a gas cylinder. Okay? I'm going to go through the proper way to change out an oxygen bottle, and you'll use this for any gas, any bottle that you do. Okay? The first thing we're going to do is we're going to shut off the bottles. We're going to bleed our torch down. And anytime I bleed or purge a torch, we only open one valve at a time. We never open both valves at the same time. We do not want to put that mixed gas coming out into the air. Okay, one gas at a time. We open it up, we watch our needles, they come down, we open up the oxygen, we do the same thing. And then we're going to take our regulator, my little oxygen regulator. take the oxygen regulator or whatever, we're gonna set it to the side. We're going to make sure that we keep this from any contamination. We wanna make sure we don't set it on an oily or greasy rag. You know, we wanna make sure that we don't just throw it down on a well table and run the possibility of putting a dent or a scratch in here, okay? Then we're gonna take our cylinder cap, we're gonna recap the cylinder, we're gonna screw it down, we're gonna then unchain it, roll it off the cart, put the full one back on, rechain it, and then take off our cylinder cap. Then I'm going to stand opposite my valve, so it points away. Obviously, we make sure that nobody is standing downstream at this point, a fellow worker. Then we're gonna take the valve and we're going to open it up and we're gonna expel some gas. Doesn't need to be open a long time. We want the pressure from the cylinder to expel any dust or dirt that may have accumulated inside that valve. So we're gonna open it up, and we're gonna shut it back up down. Then we're gonna take a regulator, we'll start the threads by hand, we're gonna take a wrench, and then we're gonna snug it up. Now, at this point, snug is good. You guys are gonna learn to talk torch today. The first thing you're gonna learn is that when you go, it's telling you, dude, it's too tight. We have brass to brass or brass to copper. When we start hearing that screeching, we're starting to stretch the threads. They're not grade 8 bolts, okay? Once we've done that, we're going to make sure that our regulator adjusting knob is turned out on both gases, and then we're gonna check it for leaks. I want you to check for leaks every time, the first time you start your torch for the day, okay? The simple way to do that is we're going to gradually open the valve and we're going to stand opposite the regulator and we're just going to slowly open it up. And then if it's a high pressure cylinder, we're going to open the valve all the way. Oxygen bottles should be either all the way open or all the way closed. Your acetylene bottles should be about half a turn open. Okay? If you have an acetylene bottle that does not have a hand wheel on it and it needs a little T-wrench, make sure you leave the wrench on the bottle the whole time it's in use. The last thing you want to do is have a fire and have to go, what the hell did I do with my wrench? Okay? I'm notorious for that. Looking for the tools. Leave it on the bottom. Okay? So, now we're going to check for leaks. So first time, we're going to turn my adjusting screw in, and what that does is, a regulator is nothing more than a shut. It's got a shut-off valve, a seat. Okay? When we open that up, that oxygen went this far, in a very small chamber inside that regulator. Okay? We've built very little friction. So as we turn the adjusting screw in, we're starting very low and we're letting it gradually build up. Okay, which minimizes the risk for friction and fire if you had a contamination in there. Okay, going to bring it up 20-30 psi. I really don't care how much at this point, but notate where you put it at. I usually use a mark, so 20 is a good spot for me. And then I'm going to open up my acetylene. I'm going to turn my adjusting screw in. Give it about 5 psi. There's a nice mark there. And then I'm going to shut my cylinders off. Then I'm going to walk up to my regulators and I'm going to back them out 1/2 turn. Then I'm going to look at all 4 of my gauges and see if they drop. If the needles start to drop, it tells you you have a leak. At this point, you need to find the leak, fix it before you go on. Okay? I will tell you most leaks will be in the hose. If you just change the bottle, okay, I just changed my oxygen, and the high pressure gauge drops down, then there's a good chance that maybe I didn't get it snugged up tight enough. Put a wrench on there, snug it up a little bit more, and then try it again. This all takes very, very little time, okay? If you can't find, if we find that the leak is up here, get a different bottle or a different regulator. I try a regulator first, okay? How do we find a leak? Bucket of water. I do not want you to use soap and water. What is soap? What's soap made out of?
Oil.
It's a petroleum byproduct, isn't it? Okay? So, we're gonna use a bucket of water. My torch doesn't care if it's in water. Now we're gonna have to open them up, or open up the bottle at the side that you have the leak on, stick the tip in, start from the end. If you got a bubble coming out here, out of your tip, you know that your valve here is leaking, okay? Problem solved. Tighten it or replace it, okay? Get a different cutting attachment. If it comes out around the packing, then you know that's where the problem is. Most problems will be in the hose. Stick the hose in the bucket of water, just like you're checking for an air tire, a tire. If you get a leak, fix it, okay? If it is up, you can't find it, we've got all the way up to the regulator. Go get you a bottle of Oxygen Safe leak detector. This gentleman will sell you a bottle, what is it, $5, $7?
Yeah, they're not very-
It's cheap,